We are now going to find domain and range of a function graphically. So remember, a number x is in the domain of a function if and only if it has a single y value in the range. So we're looking for xy pairs, and we're going to look for ranges of these pairs. So what's the smallest possible x to what's the largest possible x? And it's possible, a lot of functions, we may have domains and ranges of minus infinity to infinity, meaning it goes, if we're talking domain, this means it goes all the way from the left to the right. Everywhere has an x value with a matching y value. A range, on the other hand, of minus infinity to infinity, remember, domain is x's, range is y, so this is a vertical line stretching all the way up or all the way down. Or we're going to look for places where it stops going down or where it stops coming up, whether it turns around or the function itself just stops. That's what we're looking for. And so we're going to come here, we're going to start with our domain. And so if we were to take this graph right here, this is a nice linear graph. And if we were to take this, we were to look at it, notice this is continuing to go down and it's continuing to go up, and we're going to assume that whatever graph they give us has all of the pertinent information. So this line is just going to keep going down. It doesn't turn around anywhere, or we would have shown it. Same, this is going to go up. It's not going to turn around, it's not going to stop, or we would have shown it. So if we can assume that these keep going as far as they can, notice this keeps going and going and going and going like this, but most importantly, it appears that it's continually going to the left. And likewise, this appears to continually to be going to the right. So if we were to shrink this and get rid of the y entirely, we'd find that we'd have x values all the way along this axis. And since it stretches all the way from the left to the right, our domain is minus infinity to infinity. And any linear equation, any linear function that has a slope that's defined, not undefined, will have a minus infinity to infinity domain. Our range, on the other hand, is an up-down thing. Notice that this continues to still be going up, this continues to still be going down. When we go from down for our range, it's the lowest value I can see is minus infinity because it keeps going and going and going. But our highest thing keeps going up to infinity. And again, for a linear equation, unless it has a zero slope, it will also have a minus infinity to infinity range. Now, our next graph happens to be the graph of an absolute value. And so what we're looking at here for this absolute value is we want to see, does it keep going from left to right first? So let's look at domain first. So this keeps going to the left, and this keeps going to the right. So if I were to shrink that down, we'd be able to shade everything along this line in terms of x if the y wasn't there. So our domain here is minus infinity to infinity. Our range, though, notice this keeps going up and this keeps going up. So they're going to keep going up. They both go to infinity. So in this case, our range nicely goes to infinity. But at the bottom level, it comes right here, whatever this point is right here, and then it comes right back up. And so we're going to assume that this point, so for our y, we get this nice shading, but it comes to here, and it stops. And so in this case, we're going to say this goes from minus 3 to infinity. And I'm just guesstimating, I'm hoping that this lines up on integers, and it does because I set it up, but I'm not showing it. So unless we're told otherwise, we're just going to assume the integer value. And we're going to put a square bracket because notice we do have a point right there at the very bottom that would have that negative 3 value. And so graphically we can see, this has a stopping point in y. Somewhere it turns around. Now both of these are graphs of radicals, which is something we'll see later. And what we're looking at is, does it have a stopping point? Yes, it has a stopping point right here, and then right here it continues to go out. So it's both going to the right and it's going up. Well, that means my domain is going to go from whatever this value is. Again, we're going to put it on the integer, minus 3, and it goes to the right. My range is going to be here at minus 4 and up. So our domain is from -3 to infinity. We're going to put a square bracket because that point is there. And our range is going to go from -4 to infinity because it starts right here and then it goes up. Well, if we look at our next one, we'll notice that our point is right here, and so that translates over to here for our y. And down here, we're going to put it on the integer again at -5 for our x, and it goes to the left this time. Well, but it's still going up in range. It could go down, and if it goes down, it would just be shaped this way, and we just reverse what we do in our domain. But for our range, for our domain, notice that we hit the arrow. So that means we go from -infinity up to -5 where we stop. And our range starts at 2 and goes to infinity. So we can very quickly, with a look at the graph, see where our domain and our ranges are.